Okay, so these are the solutions for the homework in Chapter 6, Section 3. And in the first problem, we're told that we're conducting a poll by making a random survey of 1,500 people. And we want to estimate the margin of error at a confidence level of 95%. And then we want to round that answer as a percentage to 1 decimal point. So let's go back to the formula for margin of error again. So we said that margin of error was equal to 100 divided by the square root of n. And n is the size of the sample that we took in the survey or the poll. So for our case, n is equal to 1,500, if I remember correctly, 1,500. So we just put this into the formula. So for our case, the margin of error is just equal to 100 divided by square root of 1,500, which we're just going to compute out. It's not hard to do. I'll use Excel just so you see there's nothing up my sleeve. Okay, so this is equal to 100 divided by, square root of 1,500. And I'm going to do this calculation a lot, so I'm going to write this in kind of a generic form. Because I'm going to do this calculation several times actually. So this is equal to this value here divided by square root of. I want to do this partially because we're going to be using Excel a lot in the second half, so you can kind of see the sort of things that we're going to do, sort of calculations. Okay, so there's my margin of error. And remember, I want to round this to a percentage at 1 decimal place. So this means that I'm going to go ahead and I'm going to multiply it by 100 and then round it off. Whoops. Okay, so I'm going to go ahead and say equals whatever's in this cell times whatever's in this cell. And I'm going to anchor this. And if you don't know what an anchor is, we're going to talk about that very soon, actually. And then I'm going to round this to the first decimal place. And here we go. This was already, this is already to a decimal place. Never mind. The way this formula, usually when you use the formula, it's not actually percentages. It's usually a decimal. But the way this formula is set up, it's already a percentage, so we don't have to multiply it by 100. Okay, so our answer ends up being 2.58, which I'm going to round to 2.6. And that's our answer. So, margin of error problems are actually pretty easy. They're not particularly difficult problems. Where did my solution go, though? Oh, for some reason I put it over here. I don't want that. I want it up here. So hopefully you won't find them terribly difficult. Some people do. I'm not sure exactly why. It's just a really simple formula. Okay, and there we go. All right. So here we're doing something a little different. Here we're doing a sample size calculation. So it says a polling organization conducts a poll by making a random survey, and they're willing to accept a margin of error of 5% at a 95% confidence level. What should the sample size be? So if you go back up to this formula for margin of error, you notice that there's two unknowns. Okay, margin of error and sample size. And here they're telling us that they want a margin of error of 5%, and they're asking us what sample size do they need. So I'm going to use this formula, but now I'm going to use the fact that the margin of error is 5%. Make this all the same size. And now all I'm going to do is I'm just going to solve for n. Okay, I put 5 in here, square root of n, and so I can just go ahead and I can solve this equation, right? So if I solve for n, I'm going to get the square root of n is equal to 100 divided by 5, which is 20. And now I'm going to go ahead, I can just square both sides of the equation. And I'm going to get n is equal to a sample size of 400. So here all I'm doing is I'm just solving for solve for n. Oops. Oops, I see why. Okay, I'm going to solve for n here. So we're just using some simple algebra. And here I'm just squaring both sides. And so that's my answer. So I need a sample size. Oops. So I need a sample size of 400 to get a margin of error of 5%. And I can actually check that. Suppose I'm not sure if that's the right answer. I can just go back and substitute 400 in, take the square root. I'll get 20, divide it into 100, and I'll get 5. And this is how people do things in real life. They figure out what margin of error they need, and then they figure out the sample size that they have to get that margin of error. So that's how polls work, for example. Okay, for the next problem, we're looking at a story about a poll that's taken in Kentucky. And we're going to assume the level of confidence is 95%. We're always going to assume that unless told otherwise. And if we're told otherwise, then there'll be instructions on how to deal with that. In fact, there's a problem later on where we have to do that. Okay, so it says here, I don't know if this is a real story or not. I suppose it is. But this is the sort of thing that happens in real life, okay? So it says, after airing ads for the last 3 weeks, Democratic Governor Steve Beshear, he's a real person, posted a 21-point lead over Republican challenger David Williams, according to the last CNL2 poll. Beshear and his running mate, Jerry Abrahamson, received 51% of support compared to just under 30% for Williams and his running mate, Agricultural Commissioner Richie Farmer. The independent ticket of Gatewood Galbraith and D. Riley polled at below 6%, and nearly 14% said they were undecided. So you see something kind of interesting is that these numbers don't actually add up, okay? You'd be a little careful. They add up to 101. And it says nearly 14%, so you know these aren't exact. The CNL2 poll was conducted on this date by live interviews, and this is what we're really interested in. Up to this point, we don't really care about the names. We just care about these 4 numbers, okay? But here we're interested in the 802 respondents conducted for the survey voted in the 2007 or 2010 elections, or both, with about 88% of those surveyed having voted in both. The poll has a margin of error of 3.5%. Okay, so here they're saying they want you to estimate the margin of error as a percentage to 1 decimal point. And I also asked you to compute the confidence intervals too. Okay, so we just go back and we just use our formula. I'm just going to take this. It's the same formula. We just keep using the same formula, right? And here we have 802. Okay. And so I'm just going to use Excel to do this. And Excel automatically does it. Bring this over. Oops. Oh, I know why. this is going to be, let me just do it like this. Yeah. So this is 3.5%. So we get the same thing basically when we round this off, okay? So this is 802. And this ends up being about 3.5. Okay. All right, let's go ahead and compute the margin of errors also. I mean the confidence intervals also. So here we have the different candidates. So this is Bashir. And let's see, Williams is another person. And we have Galbraith. And finally we have undecided. So we have margin of errors on all of these. But the margin of errors are exactly the same. Okay, so we're told that this has 51%. This has 30%, 6, and 14. And I'm doing this Excel just for the sake of convenience, but really it's easy to do. So this is going to be the p hat minus the margin of error, and p hat plus the margin of error. And now I'm just going to take p hat, and I'm going to add and subtract the margin of error. Anchor that value. So I get 47.5, and you can see that makes sense. Take this, and I'm going to add the margin of error, but I'm going to anchor it. And if you don't know what that means, that's okay. We were going to discuss this when we do the next section on financial math anyhow. And now I'm just going to go ahead and drag everything down. And so this gives me the confidence intervals right here. And of course I want you to do these out, okay? I mean I'm doing this in Excel, but the computations are easy. And so now I know what my confidence intervals are. Okay. This is going to be 47.5 to a 54.5. So if I want to write the actual confidence interval right now, this will look like this. So we always write the confidence interval as, we always write the final answer as in what we call like an interval form, okay? See if I can do this easily. I may have to enter this in a different column here. Let me just do this real quick. So put 4 things here. Okay, so that's my first confidence interval. Then this will be 26.5 to 33.5, 2.5 to 9.5, and finally 10.5 to 17.5. Now it's important to understand what this means, okay? Computing the confidence interval is one thing, but you also have to understand what this means. This means that we think the true percentage that's going to vote for Bashir is in this interval. We don't know for sure. And you know, we're only 95% confident. We know with this method 95% of the time that the true proportion will lie in here, but we don't know if this is one of those times or not. Okay. So this is the idea. So notice that Bashir doesn't really know that he's going to win. Okay. I mean there is a chance, for example, this isn't doing what I wanted to do. There is a chance, for example, that the true proportion that are going to vote for him are below 50%. It's actually quite possible. A large portion of this confidence interval lies below 50%. So he really can't be sure that he's going to win. Okay? It's kind of important to understand that. Okay, let me go ahead and just put in the formula for the confidence interval real quick. So we say that 95% confidence interval is equal to the p hat plus or minus the margin of error. And we're just expressing this in interval form. This is just kind of a shorthand way of writing that formula. I'll put the little P hat on this time. Bink. There he goes. He's all hatted up. Okay, and so that's the answer. So this is how you'll answer. This is the form that you'll put it in. But you also want to know what this means. It means that we think the true percentage of people that will vote for him is in this interval, and all we know is that 95% of the time it will give us the right answer, but we don't know if this is one of those times. Okay. All right, so now we're dealing with different types of confidence intervals. Notice that we don't need a 95% confidence interval. We could have a 90% confidence interval. And in that case, the formula is going to change. Okay? So here, with a 90% confidence interval, it's actually smaller. Okay. Why? Because I'm less confident of the answer. If I have a smaller interval, I'm going to be less confident the true mean lies in there. Correct? Correct. Okay, so now we're going to use a different formula. So for this case, we're going to use this formula right here. We're going to say now for the 90% confidence interval, the margin of error is equal to 82 divided by the square root of n. And notice that if I give you a different confidence, a different confidence level, I'm going to have to tell you what this formula is. There's no way that you could know. Well, there is a way, but we haven't studied it. So there's no way in this class that we could know it's 82 divided by the square root of n. Okay. So now we want to go ahead. We just want to do some calculations using this formula. Calculate 90% margin of error, confidence interval, a margin of error for a 90% confidence interval. So let's go ahead and just take that out. There's our formula. And now we're told that we're going to survey 1,000 people. Okay, and we want to know what the 90% confidence interval is. So here we have this, and it's going to be 1,000, and just substitute it in. It's the exact same idea, right? I'm going to have to change this to 82. And this to 1,000. And we change the font size. There we go. And now we just compute out whatever this is. I'm just going to use Excel to do it, but it's easy to do in a calculator. So here I'm going to use 82. And my n here will be 1,000. And my margin of error is just going to be equal to this divided by the square root of 1,000. Okay, and I'm going to go ahead. I'm going to do this calculation more than once, so I'm going to anchor this value. Boop. Whoops. Hold on a second. I want that. Okay, there we go. And I'm going to round these off to just one decimal place. Okay, there we go. Okay. So our margin of error is roughly about 2.6%. And it's probably not a bad idea to put percentage, even though it should be obvious. A margin of error is either a decimal or a percentage. If it's not a decimal, it has to be a percentage. But we'll go ahead and, whoops, I want 1,000 there, don't I? Okay, and there's our answer. Now, if you calculate that out with 100, you would find that the answer would be a little bit bigger, because the 100 here would cause this answer to get a little bit bigger. But again, you know, if I make the interval smaller, I'm less confident. So notice that here I'm less confident. I went from 95 to 90%. So this interval should definitely be smaller. And I think I asked you to calculate a confidence interval, but you can't do it for this one because I don't actually have... Oh no, this is 15. I'm looking at 16 and 17. Yeah, I want the confidence interval there. Okay, so for 16, we're conducting a poll using a representative sample of 1,000 people. That's the same as saying random sample, because a random sample is supposed to be representative of the population if it's truly random, right? To find out how many people like salad, and we find that 53% of the people say they do, and we want to find a 90% confidence interval and then explain what it means. Okay, so let's compute the margin of error. Here's what we know. We know that the confidence interval is equal to this. I know p hat's 53%. So here we know that p hat's equal to 53%. Let me change the default setting on the slide. This is a pain. That's the problem right there. Actually, let me leave that. Okay, that's good. Okay, so I want p hat to be 53% here. And now I have to compute the margin of error. But it's at a 90% confidence level. I'm going to use this formula right here, right? So I know that the 90% confidence interval is given by this. I have 1,000 people again in my poll. Well, I just did this calculation, right? So it's easy. So I'm just going to add and subtract 2.6 from 53. So my final confidence interval will be I'm going to get here 53 minus 2.6, so I'm going to get 50.4 for the lower value. And then for the upper value, I'm going to add 2.6, so I'm going to get 55.6. Okay. And that's going to be my 90% confidence interval for the true population proportion. Now, how would we explain this? Okay, it says, can you assert with confidence that the majority of Americans like salad? And we have to explain what this means. So the explanation is going to be that we are 90% confident that the true percentage of, Americans like salad is between 50.4% and 55.6%. Okay? And can we assert with confidence that the majority of Americans like salad? Well, what's the majority? Over 50%. And I'm 90% confident that I'm in this interval, so I'm 90% confident I'm above 54%, so I would say yes. So we could say if we're 90% confident, true percentage is within and since all the values are over 50%, we are at least 90% confident that the majority of Americans like salad. And I say at least because notice that the true population proportion could actually be above. Okay, so there's values up here, and if there are values up here, it's possible there's a 10% chance the value lies outside this interval, and so we actually could lie above. So we're actually more than 90% confident that the true value is above 50%. So notice that the interpretation takes a little bit of thought. What I'm doing is I'm looking and seeing where 50% lies relative to this. And this entire interval lies above 50%. And I'm 90% sure the value lies here. So I'm 90% sure that it's greater than 50%. I'm at least 90% sure in this problem. Okay, so we're continuing on with this 90% confidence interval. So I'm just going to take this formula that we have here. This is the margin of error for the 90% confidence interval. And suppose that now, someone else took a survey and they found that, say, 48% of the people like salad. And now we want to compute the margin of error and the confidence interval here. Well, we actually got the margin of error because it's exactly the same sample size, right? So I can actually just cut and paste all of this. I'm just going to use this basic format. Okay. So I know the margin of error is this, but now p hat's 48%. Okay, so now when I do this, I still get the same margin of error, but notice I have to subtract and add 2.6. Okay, so now when I add and subtract 2.6, I'm going to get 45.4 down here, and then I'm going to get 50.6. Okay, now notice that 50% lies in here. Okay, and so you kind of have to look at this interval, but 50%, if we look at this interval, basically lies at the far end of this interval. So I'm not 90% sure it's less than 50%. So let's just draw a picture real quick. Take a look what's going on here. Let's see. Okay, so here's my confidence interval. Let's see. So here's kind of what's going on here. So my 48% is here. Okay. I'm going to have my two endpoints here. So there's one endpoint, and these are symmetric, okay? And so this ends up being, this is 48. Make this a little bigger. Okay, so this is my p hat, right? Oops. Okay. This is 50.6 right here. This is the lower end point of the confidence interval, which is 45.4. And we think that the true value lies in here. We're 90% sure. Okay, so we're very, very sure that the true value lies in here. And I want to know, how confident am I? Let me just kind of make this a little dark here. Okay. So I didn't want to do the whole thing. I want to do this guy here. I hit the wrong guy. Okay. There we go. Okay, so, and I don't even need this anymore. Okay, so I'm 90% sure the true value lies in here. I want to know, how confident am I that the value is less than 50%. So now I'm talking about these values right here. And I'm just going to kind of guesstimate where 50% is. Let's just say it's here. Okay. Well, notice that this is the majority of the interval, right? I'll make this really large. mean, if I take this as being 50%, this is the majority of the interval. So I'm not 90% sure. It's not the whole interval, but I am pretty sure. Okay, so here, although I'm 90% sure here that it's between 45.4 and 50.6, the majority of the interval lies below 50%. So this is the salient issue here. So even though I'm not 90% sure, I'm not 90% confident that the true population proportion is below 50%, proportion is below 50%, I am still very confident. Maybe I'm 80% confident or 85% confident, something like that, okay? So this is a slightly nuanced question. All right, for 18, we suppose that we want to have a margin of error of 2% with a 90% confidence interval. And we want to go ahead and use the formula to just calculate this. So let's go ahead and do this. So I'm going to use my formula. The 90% confidence interval is going to be 82. And I'm basically going to solve for the sample size. Okay. I know here that the margin of error is going to be 2%. And I'm just going to go ahead and solve for n. So n is going to be equal to 180 divided by 2, and I'm going to square this whole thing. Sometimes we have to round off. When we round off, we always round up. Okay, and that's just going to be 41 squared. Not hard to do, but we'll just do it right here. 1681. And of course, we don't have to round off. Okay. But it is possible, for example, if I had a margin of error of, 2.3%, this would not have worked out to a nice number. Then we always round up. That's kind of the conservative way of doing this. So basically, we need to interview or take a poll of 1,681 people to get this margin of error. And this is a nice result because, the margin of error in the news is usually about 2%. And so you can see that you need roughly, about 1,500 people to get a margin of error of 2% with a 90% confidence level. If I wanted to make this confidence level higher, 95%, I need 100, and this would be larger. Okay? So then I might need a little bit under 2,000 people. Something like that, okay? In fact, we could figure it out really quick. 100 divided by 2 is 50. Squaring 50 is going to give us 2,500. So you can see somewhere in the ballpark of 1,000 to 2,000 people actually gives you a pretty good margin of error. Okay, that's all for these problems. These are good problems to think about and study. If you have any questions, of course, feel free to ask me.